Hey guys! Here we go, second video on force and motion. Let's get started. So you have a graph, and let's get our axes here. Make two graphs. First graph, we'll go time, and remember, I'm just going to put D for distance. I'm going to change the thickness of my pen. Okay, so if you have a graph, and your graph that you're graphing the motion looks like this, okay, there are things that you would know about this. Okay, first, this is constant velocity. Okay, constant velocity. So that means that you have a slope that is the same no matter where you are on the line. Your run to your rise is always going to give you the same slope. Okay, and so that is your velocity, constant velocity. It does not change. Very unlikely, but this was when we rolled the cart. There's our little cart, little physics cart, little bumper thingy, and it's going zoom, okay, and it's going along a flat track, okay, so we would get constant velocity. Okay, so now if you have the axes, and you have your time, and your distance, and what color should we make our graph? Let's pick one of the crazy colors, and we'll just go green. Okay, and your graph looks something like this. Oops, we missed the color there. Sorry about that. Anyway, if your graph looks like this, you have something going on. This is a parabola. It's not a straight line. And this means that your velocity is not constant. So for example, here I go my rise over my run versus here my rise over my run versus here my rise over my run. You can see it's much different. Okay, the rise, let's assume the runs are all the same here. You can clearly tell that this rise is short, this rise is bigger, and this rise is really big. Okay, so in this particular graph, velocity is changing. And if velocity is changing, remember, what was changing velocity? That means, and we'll change color here, you've got something that is accelerating. Whee! Okay, so this is an accelerating item, okay? And this, I'll add another here, was when we had the cart. Here's a little block, and here was the track sitting there, and then let's draw our cart in orange, why not? Then we had our cart sitting on the track, there's a little bumper, and it's going down, but as it goes down this way, it's going to go faster and faster and faster until it hits the bumper at the end. So that's our accelerating cart, and if you remember in class, we talked that why was the cart accelerating? Well, there's a force that's pulling down on the cart, force of G. See if you can think about what that is. If you have an incline like that, that's going to be acting on the cart to make it go faster so that you get a graph that looks like the parabola. All right? So that is a graph where you will find acceleration.